King Hero ordered a new crown to be made from pure gold. When he received the crown, he suspected that other materials had been used in its construction. Archimedes discovered that the crown required a force of 4.7 pounds to suspend it when immersed in water, and that it displaced 18.9 cubic inches of water. He concluded the crown was not pure gold. Do you agree? Now, I really like this problem a lot. This is really comes to where that story that I told about the bathtub earlier in the lecture came from, and this really did happen. But this also requires us to think a little bit about the problem to solve it, which is why I really like it. So let's take a look at it, and we're going to draw a free body diagram of our situation so we can start to get a handle on what's going on. So we have the crown here in the water. Oh, that's a horrible crown. This is why I am not an artist. So for that crown, I know that it's got some weight, some mass gravity pulling it down. I know it has some force of buoyancy that is pushing up on it. Now, this would sink normally, but we also have, we'll call the force WA, so the weight Archimedes is pulling up on it that balances things out. So now as I look at this, the sum of the forces in the y direction have to equal 0. So we have the mass gravity pulling down, so that's our weight. And then we've got, and that's going in a negative direction, we're going to add to that the force of buoyancy, and then the force that Archimedes is pulling up on it. So that tells us that the weight has to be equal to the force of buoyancy plus the weight that Archimedes is applying to the crown. And okay, so we can look at this, and the force of buoyancy, well, we know what that's going to be. That's going to be the gamma of the water, gamma of H2O, and then we have to multiply it by the volume of water displaced. So the volume submerged. We know what that volume is because it's completely underwater, so we know that's going to be 18.9 inches cubed. So what's the weight of the crown going to be? Well, the weight of the crown itself is going to be the specific weight of the crown times the volume of the crown. And once again, we know it's displacing 18.9 cubic inches. So for this case, our volume and our volume submerged are going to be equal to each other. And so I know the weight that Archimedes is applying is 4.7 pounds. So if I look at this then, I've got the specific weight of the crown times the volume of the crown is going to be equal to the specific weight of the water times the volume of the crown plus the force that Archimedes himself is applying. Now what I'm really after is I want to know what the specific weight of the crown is, because that's how I'm going to identify whether or not it's gold. I'm going to calculate out the specific weight. That'll give me the density, and then I can go look up, okay, is that the density of gold? So the specific, that is a terrible gamma, the specific weight of the crown, I'm going to divide through by my volume, and so what I'm going to get is the specific weight of water plus the weight that Archimedes, or the force that Archimedes is applying, divided by the volume of the crown. So now if I plug my numbers in, well, the specific weight of water, 62.4 pounds per cubic foot. I'm going to add to that the weight that Archimedes is applying is 4.7 pounds, and then we're going to divide by 18.9 cubic inches. Now on one side I've got pounds per cubic foot. Over here I've got pounds per cubic inch. That's not going to work out, so we've got to make a small conversion here. So 1 foot divided by 12 inches, and then I will cube that to get the proper units, and that will end up giving me pounds per cubic feet. So now if I go and I plug that in my calculator, the specific weight of my crown is going to be 492.1, and that's going to be pounds force per foot cubed. And so now that I know that specific weight is density of the crown times gravity I can divide through by gravity, and what I'm going to find is that my density of the crown is going to be 15.3 slugs per cubic foot. So now what I can do is, okay, like that's my density. I'll go look at my periodic table, and I find out that that's not really the weight of gold. Gold's actually heavier than that, and the density of that crown is about the same as the density of steel. So King Hero is definitely being ripped off here. There's probably steel with just a plating of gold around it. So we should be agreeing with Archimedes that that crown is not gold.